Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video I am going to discuss about rotation. Rotation is one of the type of curvilinear motion where the center of rotation is constant. So let's start the discussion of rotation. So here, as I told you about the motion of the particle, so motion of the particle we generally define as the relative change in position of the particle with respect to fixed body or fixed surface. And here, if we define the motion, so basically there are two types of motion we consider. One is the rectilinear motion and another is the curvilinear motion. So rectilinear motion is related to straight line motion and curvilinear motion is always related to motion along the curve. So if we are considering any particle is moving along the curve, so that is curvilinear motion. And curvilinear motion is further subdivided into plane curvilinear motion and rotation. So plane curvilinear motion when the particle is moving along the curve and the center of the curve is continuously changing. So this is called plane curvilinear motion. But if we talk about the rotation, so the particle of the body move in a centric circle. So the rotation will be represented as the movement of that particular particle along the periphery of the circle. And here the center of the particle is not changing, or we can say the center of the rotation or the center of the movement of the particle along the curve is not at all changing. We will consider constant center. So here I am going to discuss about the rotation, and the path followed by the particle, either it is straight line or it is curved, or if it is a centric circle, so that particular path is called trajectory. And here I have discussed about the term kinematics and kinetics. So basically we are dealing with the kinematics, and in a rotation we will find out the velocity, acceleration and displacement only in terms of rotation. So in kinematics we will describe the motion without causes of motion. So we will consider the term velocity, acceleration and displacement. So if it is a rotation term, so in terms of rotation we will find out angular displacement, angular velocity and angular acceleration. So if we define rotation, so basically motion of the particle along a circular path and the center of the rotation does not change. So this particular motion we call rotation. Rotation we can define as the motion of any particle along the wheel of the automobile, that is considered as the motion of the particle under rotation. So if any particle is moving along the circle, that is called rotation. And here we can define the rotation of any particle with the help of three terms: displacement, velocity and acceleration. And acceleration we consider as angular acceleration. So first of all, I will discuss about here angular displacement. So as you can see here, this is the diagram and this particular circle is representing a curved path. And if any particle is at one point of this particular circle, let us consider the point A, and at this point A, any body or any particle is placed, and this particular particle is moving along this particular circle in this particular direction or opposite to this particular curve. So if any particle is moving in this particular direction, you can see here the another point, that is point B. So here when the particle is reaching the point B, it means it is following this curved path, and this is the part of this circle, and we have a center of the circle, that is O. So the center of rotation for this particular particle which is at point A, and if it is reaching the point B, it will be O only. So either the particle here at point A or the particle here at point B or in between A and B, the center of rotation will be constant. The center of rotation is not at all changing. And if we are considering change position of the particle from A to B, so this particular term is represented by the angle theta. So here the displacement from A to B of the particle is generally represented as the angular displacement because it is represented by the angle theta. So this angle AOB is generally representing the angular displacement, and this particular direction of the angular displacement can be clockwise or it can be anti-clockwise. The particle can move in this direction or it can move in this direction, but it should follow a circular path with constant center. And here we are considering a small angle theta between A and B, that is represented by angle AOB. So this is representing the angular displacement of particle from position A to B. Now if we are considering this particular particle is completing this whole circle or completing the periphery of the circle, and it is returning to its original position. So this particular term is generally representing the revolution. So here when the particle is starting from point A and it is coming back to its original position A, so this is representing one revolution of the particle. So one revolution of particle is always equals to 360-degree angle or 2 pi radians. So if the particle is completing a complete circle, or if it is completing the path of the circle, if it is returning to its original position, it means it is covering 360-degree angle or 2 pi radians angle. So this is about the displacement of the particle along the circular path. Next term is related to angular velocity. So if we talk about angular velocity, so angular velocity depends on the angular displacement. So rate of change of angular displacement of the body or the particle with respect to time is called angular acceleration, and it is generally represented by omega, that is equals to d theta by dt. So this d theta is generally representing the angular displacement and dt is the time. And as per this omega equals to d theta by dt, we can define the unit of the angular velocity. So it will be radian per second. So this is the unit of angular velocity, radian per second. And if we are considering complete revolution of the particle with the angular velocity, so number of revolution for the particle we generally define by n by 60. So if we are defining number of revolution per second, it is represented by n by 60. N is the number of revolution and dividing by 60, so it is representing per second. So we can define in this particular term the formula of the angular velocity, it is 2 pi n by 60. So this is another formula of the angular velocity. Now let's move toward the angular acceleration part. So angular acceleration is related to angular velocity. So if we define angular acceleration, so angular acceleration is generally defined as the rate of change of angular velocity of the body or the particle with respect to time, and it is generally denoted by alpha. So alpha is representing d omega by dt, that is change in angular velocity with respect to time. And if we further simplify this equation in terms of angular displacement, so it will be, the equation will be d by dt, d theta by dt. Here omega value we are putting, that is d theta by dt, so it is equals to d square theta by dt square. And if we further simplify this equation, so it can be alpha equals to omega d omega by d theta. So this is the equation of the angular acceleration. And if we define the unit of the angular acceleration, so as per this, the unit of the angular acceleration will be radian per second square. So this is the unit of angular acceleration. And if we want to define the relation between the equation of the linear motion and the rotary motion, so the equations will be, these three equations are representing the relation between rotation and linear motion. S equals to r theta, V equals to omega r, and A is equals to alpha r, where r is representing the radius of the circle, and this theta is representing the angular displacement, S is representing the linear displacement, V is the velocity, omega is the angular velocity, A is the acceleration for the linear component, and alpha is the angular acceleration. So these three equations are generally representing the relationship between the linear motion and the rotation. So this equation we will use to solve different equations. Now if we are considering this particular curve is the curvilinear path, and here any particle is moving along this particular curve. So here we will consider the tangential component and the normal component both. So the tangential velocity and the normal velocity we will consider, as well as tangential acceleration and normal acceleration we will consider. How we are considering? Here I am going to discuss with one diagram. So here let us consider this is the circular path and this is the position of the particle. This point P is representing the position of the particle. And if this particle is moving along this curve in this particular direction or opposite to this particular direction, so this particle is following a path. It means it has some normal component as well as the tangential component at this particular point of the curved path. So if we are considering the tangential acceleration here in this particular direction, and it is represented by alpha t, and the normal component perpendicular to alpha t, here we are considering toward the center O. So this alpha n is represented as the normal component, and if we are considering alpha, this particular line is representing the resultant acceleration or resultant angular acceleration. So this resultant angular acceleration we can define in terms of alpha t and alpha n. So first of all, we have to define the value of alpha t and alpha n. So this tangential acceleration we generally define on the basis of alpha and r. From this diagram you can see this alpha t is following some path. So this alpha t we can define with the help of alpha and r. So the equation of alpha t will be alpha r. Similarly, if we want to define the normal component of angular acceleration, so the formula of the normal acceleration, it is represented by alpha n, so it will be v square by r, that is equals to omega square r. Now we have the alpha t and alpha n, so we can find out the resultant. So the resultant angular acceleration will be under root of alpha n square plus alpha t square. Now here if we are considering the resultant acceleration is making an angle phi with the radius, so that particular angle we can define. So this particular angle phi we can define as tan inverse alpha t by alpha n. So with the help of this particular angle we can define the exact position of resultant acceleration. So this alpha t is generally representing the tangential acceleration, and it is due to change in magnitude of the tangential velocity, and this normal acceleration is generally considered here in this particular direction. This particular alpha n we are considering in the normal direction or toward the center. So if we are considering this is the point, so this alpha t will act somewhere here and alpha n will act somewhere here towards the center. So this is, we are considering along the normal velocity or the normal component of velocity or normal component of angular velocity, and this alpha t is representing the change in tangential component of the velocity. So this is the complete description of rotation. Now here I am going to define different equations of the circular motion. So these equations are related to angular acceleration, angular velocity and angular displacement only. So these are three equations which is based on the rotation of the particle along a circle. So it will be omega equals to omega naught plus alpha t, omega square minus omega naught square equals to 2 alpha theta, and theta equals to omega naught t plus half of the alpha t square, where omega naught we are considering as the initial angular velocity of the particle, omega is the final angular velocity of the particle, alpha is considered as the angular displacement, and theta is the angle moved in time t. So this is the description of equation of circular motion. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.